Okay, right? So see here problem. మనం ఒకసారి గ్యాస్ టర్బైన్స్ లో ప్రాబ్లమ్స్ చూద్దాం. లుక్ ఎట్ హియర్. మనం ఇక్కడ చూసినట్లయితే ప్రాబ్లం 4. ఏ కాన్స్టెంట్ ప్రెషర్ ఓపెన్ cycle gas turbine plant. Gas turbine plant to open cycle gas turbine plant works between temperature range of 15 degrees and 700 degrees Celsius and pressure ratio of 6. So pressure ratio is given here. That means here we take P2 by P3, that is equal to P1 by P4, that is called 6. Then find the mass of air circulating in the installation. If it develops 1100 kilowatts, also find the heat supplied by the heating chamber. Heat supplied by the heating chamber. This is the problem is given. Right now, see my notebook, how to solve this problem. Solution. I'm going to write given data first. So I take 15 degrees Celsius is given. That we take from T4. Why? Because in turbine. Okay. Then that is equal to 15 plus 273. Totally we'll get here 288 Kelvin. Similarly, T2 is equal to 700 degrees Celsius is given. So then 700 plus 273, that is equal to 973 Kelvin. The pressure ratio is given. So P2 by P3, that is equal to P1 by P4, that is 6. And now the total power is coming from here, 110 kilowatts. Okay, 110 kilowatts. Here, mass of air circulating in the installation. Mass of air circulating in the installation. Let M is equal to mass of air circulating in the installation. Okay, then that is mass M, and now T1 and T3. T1 and T3. This is temperatures of air after isentropic. After isentropic compression and expansion. Parallel గా notes తీసుకోండి, నేను రాస్తున్నాను కదా, అవి మీరు రాసుకుంటూ వెళ్ళిపోండి. Process. That means here 2 to 3. Okay. So 2 to 3 means here we are going to take cycle here. This is open gas turbine cycle. 3. This is 4. Coming air, outlet of air, exhaust air. We know very well this is turbine and this is compressor. The cycle here we are going to fix combustion chamber CC. Now this is generator. Okay, here we see 2 to 3. Now this is coming from 3 turbine. We say 2 to 3. So then we can write here the equation of 2 to 3, T3 by temperature range between, that is equal to T3 by T2 whole power gamma minus 1 by gamma. Then 1 by 6, that is called pressure ratio. 1.4 is gamma value standard. Okay. Then you can find out this is temperature ratio. Okay. So therefore, T3 is equal to, you can write T2 into 0.599. Look at this. T3 by 22 is equal to ఇది. So then T3 we need means T2 ఈ పక్క వచ్చేసింది. So we know very well T2. Substitute, that is given. Then the answer is here 583 kelvins. Okay. Now similarly, for isentropic, similarly for isentropic compression process. Isentropic compression process. Then that is coming from here 4 to 1. The compression is coming from here. This is compressor, then this is turbine. So here is 4 to 1. C. This is C. C means compressor. Here 4 to 1. So then you can write here T4 by T1, that is equal to P4 by P1 gamma minus 1 by gamma. Then 1 by 6, 1.4 minus 1, 1.4. That is coming from here 1 by 6. We just calculate. Okay. Here also we coming the value like. So therefore T1 is equal to T4 divided by 0.599. So 2881 T4 is given. To solve this, we will get the answer here 481 Kelvin. Okay. So why? Because here we are going to find the heat supply. Okay. So heat supply, then we need all those values. So now we are going to see work done by the turbine per kg of air. So work done by the turbine, by the turbine per kg of air, WT, that is equal to M into Cp, then T2 minus T1. This is the equation. Now substitute the values here. M, we don't know, 1, and into Cp can take 1 value. Temperature 2 is find out, temperature 1 also find. So here we'll get the answer 390 into mass M. That is the kilojoules per second. Similarly, we are going to see work absorbed by the compressor. So by the air. So M into Cp T1 minus T4. The temperature, why? Because compressor is acting 4 to 1 and turbine is acting 2 to 3. That's why we take here T2 minus T1. Here we get for T1 minus T4. Now substitute these values. Here also M we don't know. T3 can take 1 and T1 is given and T4 also given. So then here 193 M kilojoules per second. Okay. Now we are going to see here net work done. So therefore net work done. So therefore, net work done by the turbine load Okay, then now we see here work done, net work done, W is equal to WT minus WC is the standard formula. Okay, so this standard formula you can take here. WT already we find 390 m minus 193 m. M means mass of air. Okay, then here we calculate this 197 m kilojoules per second. So now here we are going to see power required. So how much power developed we want to see. So power developed by the installation. That's called here P. So then P is equal to 197 M. So already we know very well P is given here. You can see given data. P is given here 110. Okay, and now then we can go to substitute this one. Here I need M. Okay, simply I can write this thing. M is equal to 110 divided by 197. Okay, so now calculate this. Approximately we'll get this kg per second M value, mass. Okay, once you find this mass, you will get the heat supplied. How? We'll see here heat supplied by the heating chamber. హీటింగ్ ఛాంబర్ లో ఎంత హీట్ అనేది ప్రొడ్యూస్ అవుతుంది అనేది ఇప్పుడు మనం కనుక్కోవచ్చు. there is one equation. Okay, that equation is equal to m into Cp. Here heating chamber, where is heating chamber? This is the heating chamber. There is a 1 to 2. The combustion chamber is called heating chamber. Then here 1 to 2. So T2 minus T1. So you can take here T2 minus T1. So now M already we find 5.58. This take 1 and T2 we know, T1 we know. So then you can solve this. Approximately we'll get the answer here 2745.4 kilojoules per second. Okay, this is the solution part of this one. Okay, and so now you can ask any doubts. Or మీరు ఏదైనా కాపీ చేసుకుంటాం సార్ అంటే నేను స్టే చేస్తాను. So then you copied this problem. Yeah, okay. Now, okay. Nagesh, Yes, okay. And now this thing. So Nagesh absent today, right? Okay.
Yes, sir.
Yeah, yeah. Now, who's next? Ramesh, anyone? You can take attendance, okay? Screenshots. I'm also taking. You also take the attendance and send to your group. Okay. Now I'm going to stop the 1 minute.